Good afternoon, everybody. Thank you for joining today's webinar on pore pressure prediction for velocity modeling. Just a few guidelines. So throughout the presentation, if there is a question that you may have, feel free to type it in your question panel box. And at the end of the presentation, if there's enough time, we will go through the questions. There's also information at the end of the webinar we'll be sending to you. Okay, so today's presenter, her name is Hilda Prada. She's located in our Crawley, UK office. She brings more than 27 years in the oil and gas industry. She provides knowledge transfer, training, and support for all of our clients using our Hampson Russell, Inside Earth, and VelPro technology. She achieved both of her bachelor's and master's in integrated reservoir management from Universidad Central de Venezuela. And she has a strong focus on seismic interpretation, 3D geological framework, mapping, velocity modeling, AVO analysis, well and seismic data management, and multi-platform environments. And with that said, I'll hand it over to you, Hilda.
Okay, well, good afternoon, good morning for everyone. Thanks for joining us. Well, we are ready to start with the webinar today. The webinar is about pore pressure prediction. This is one of the functionalities contained inside our VelPro software, which is the velocity modeling software. And as you can see, it is part of the groups of application around the CGG Geo software suite. Going back in the pore pressure prediction, what we have here as on the principal problem that we have. The fluid pressure is a function of effective stress, but which is a function of the velocity as well. We can get the velocity from seismic, but sometimes the velocity needs to be properly calibrated. We can calibrate that using the well information, but usually there are no wells already available in a survey, or the sonic logs are not available over the required interval. If we have well logs, we could use this information in many different ways. We can calculate coefficient for equation to calculate effective stress and fluid pressure. And this is one of the key issues for the module in pore pressure prediction that we are going to see this afternoon. Inside VelPro Solutions, we got different workflows. We can create our velocity model using independent, structural independent modules, workflow, or if we have horizon interpretation, we can use and create a velocity modeling in using the layer-based modeling workflow, or we can use as well additional after calculating and creating our velocity model. We can take advantage as one of the functionality, which is the pore pressure prediction model. What we are doing here, we are deriving the normal compaction velocity to a layer from well data. And we are going to calculate the pore pressure volume and some other volumes, additional volume that we can calculate with the algorithm. How it works? Normally, the typical workflow that we are using, as usual, we are loading the control logs. We create a calibration function. After that, we can build a calibration volume and calibrate the seismic velocity, which should be ready to go to use and initialize the pore pressure prediction model. And then we have an additional functionality inside, which is to calculate the density volume, and this is the density fit equation to generate the trend. And then after that, we are going to generate the different volume for pore pressure, factor gradient, effective stress, overburden, and density, and everything from the velocity volume. After finishing and generating all the different volume, we can extract prediction values for the well location using the volume that we just generated in the previous step. The data we need the logs, solid and density. We can use any of the Muglow drill steam test and formation tests if we have this available in in the well for the QC, seismic stacking velocity, and of course the geological interpretation of seismic and well information. This is a typical view. That's our main window where we are displaying the structure, some wells, and the background of the velocity volume on it. How it works? For pore pressure prediction workflow, we are using the seismic velocity already QC. We calibrate the seismic interval velocity to the wells. Then we proceed and model and compute the pressure velocity trend function. After that, we can calibrate the compute pressure gradient to observe well data if we have this data available. And then we can compute the pore pressure volume from the velocity model and additional pore pressure parameters. And finally, we can extract the overburden gradient volume, pore pressure gradient, fracture gradient, density volume. How it works? We can use the 3D seismic velocities. We can check the wells in the area. We can check the well line logs, some of the examples. And in the right panel is that this is a capture from our project in VelPro, an example of the different logs that we have in for the wells in there. And you can see that some of them are the logs related with the pressure information that we have for those wells. Basically, what we are using is a standard concept. What we are using in VelPro, what we are doing, well, we have the this theory in the concept for that, and we have the overburden, the total overburden stress. We can just subtract that from the pore pressure, and we have the effective stress. And then using this principle, we are just going to run our workflow using VelPro. And in the way that we are doing that is, well, what is the reason that we are doing this in VelPro? Well, because we need to predict the pore pressure, and then we can display all the different responses in a single plot, and then compare what's happening in that and detect the possible risks that we have in for the well planning. This is only an example, and here is based on Eaton-Bowers 2001, and we have an example, the overburden gradient, in yellow, the fracture gradient, and the mud-weight gradient, and doing all the comparison in there, and we can then detect which one are the different responses on that, comparing the different logs, and then checking where the risk is present. Based on these principles and theory, what we are doing in pore pressure prediction, we are using the calculations based on the Eaton and Bowers equation. And for the pore pressure, we are using the Eaton equation based on the water depth, normal pressure, and Eaton exponent. And it's basically, we can see here, it's the pressure is a function, direct function from the interval velocity observed in the point. For the Eaton-Bowers, is another option that we have in here to select. It's based on the gamma values. And Bauer method is using velocities and total depths. And all those equations that we have available are based in this principle. The pore pressure is overburden pressure subtracted from stress pressure, effective stress. And this is the main reason that why we are using this and the way that the interface is presented. To start in pore pressure prediction, we have this. This is the interface of VelPro. We can see the display in red are the velocities, calibrated velocities, some wells that we have in the area. And we have the option to select those velocities as a single point. When we are selecting the option to open the pore pressure prediction, which is this window, we need to select the velocities, and every time that we are selecting the velocities in different parts of our survey, we will see the response in here in different colors, and then it will calculate the equation for the velocities and the equation for the pore pressure, the density, and stress in the right side. What we have here in this example, we have normally what we are comparing is the normal pressure train, and we can see that in red, and it's normally augmenting with the increasing with the depth, increasing the velocity, and then something is happening here more or less at around 5,000 feet, 5,500 feet in this example. And then when we are see that there is a deviation of the responses in here, which means that from this point going deeper, we have some overpressure in that, and that's what we are going to measure and detect. As we can see in this panel, we have the equation to fit. In here in the pull down menu, we have different equations to select. We can type different parameters in here. If you got the numbers, you can type in there, or simply you can click on fit, and the software automatically will calculate that for the normal train. And what we are doing is just calculating the normal train, and we will use that to extrapolate the values and calculate the full volume using the wells as an input. And in the right side, we have a different equation as well. It is very good to mention that this equation are empirical equation, all taken from the normal theory that we all know about that. And we have under the pull down menu different equation for pressure, for density, and for stress. Again, you can type and in any moment you can just change the values in here and put your own number, or you can just allow that the software calculate everything. After doing this first analysis, we can see is in that example of I wanted to show you in different ways to calculate the pressures and using different equations, and you can see that the trains is more or less the same, but there are some difference, and it's up to you. Just decide which one is the equation that better fits to your field, your survey, and then you will decide which one is the best response. It's only to let you know that according with the equation, we have similar responses, but of course, there are a slightly variation on that. This pore pressure module in VelPro, what it have the calibrated velocities, what's showing in black. We have the normal pressure trend, which is in red. It should be the normal pressure trend, and you can see the calibrated velocities in black that showing some deviation for the normal pressure trend. And in this specific example, we have the changes start at 6,000 feet, and in the right side we have the calculation using two different methods: the Eaton method and the modified Eaton method, also known as a gamma Eaton-Bowers method. We have in here that red is the pressure, the green is the overburden gradient, and the blue is the fracture gradient. And all those different trends are calculated using the equation that we have at the control at the bottom of the window. And then after calculating the first part, we even have an additional feature to adjust even more our pressure prediction calculation. We have this density equation fitting. What it does, we can just plot several wells, and then based on those wells, we are going to calculate the density trend using the responses from the wells, and with this density trend, we can then generate the whole volume for the area. What we need to do is in this density equation fitting, we select the different wells, and then adding the wells in here, selecting the sonic log and the density, And then you will see the list of all the wells that you are using for the trend. Every time that you are adding more wells, this trend equation is the regression line is adjusting using the real data from the wells. And finally, you can click on fit and then get the equation calculated automatically for you using the well data. Once you get the equation, the final equation for the wells, you can save this equation, and then you can add and load this equation going back in the pore pressure prediction module. We have the panel for the density, and then in the density, we can load this saved equation calculated using well data. And of course, it will improve the accuracy of the data that we are getting in here. What we are creating that in an easy way, because we are simply using the velocities, calibrated velocity for that. And then using the seismic velocities and well data, we are just selecting an option to generate the volume, and we can create pore pressure, fracture gradient, overburden gradient, vertical effective stress, and density volume. And what is the advantage of calculating all those additional volume in here? Because we are going to plan safer wells, because we have more information to support. When we are selecting the option to generate volume, we just need to select the velocity volume that we are using for our study, and then automatically it will fit the name for the different 5 volumes. When you click on OK, you are creating all the different volumes for the entire survey. So we are using well data, and of course the logs along the well bore, but this data is used in pore pressure prediction module to extrapolate this information and this calculation in the whole survey. And this is an example of all the different volume that we are generating on that. In summary, we can just use this pore pressure prediction study with multiple data source, well logs, basically, and seismic velocity, and applying the standard equations. It will allow better time depth conversions. Before finishing that, I would like to show you only a quick display how it is. I'm not going to run the whole demo, but I have here the velocity, the seismic velocity in red, and some of the wells. And when we are just calculating that, we select and open the pore pressure module. And if you are just interested in see the trend, every time that you are selecting velocities in here, it will plot the velocities. You will click in fit, select the distance or the depth of the standard normal trend. Let me just try with this. And then it generates the trends for the logs and the trend for this survey using those velocities. After that, we can generate the volumes. We can extract and from using the volume just calculating in this part. We can just calculate along the well bore. We can calculate the logs using an X and Y coordinate that long or well location. The more useful is just calculating and extracting using the volumes and extracting the logs. It will generate a log using that. When you click extract, it will create in my wells the log, for example, pressure, and then we can display in a cross section and then QC with the real logs in the well, plus using the background on the different volume generated in pore pressure prediction, and we can QC our data. Going back in here in the presentation, we have then and now some other additional information. Jasmine?
Great, thanks a lot for your presentation. and for the quick demo. And if anybody's interested, we can certainly go into more. So for those of you that would like more information, you can visit cgg.com/VelPro, and it'll give you more description of our velocity modeling applications. And it'll actually give you a description of some of the workflow that Hilda addressed here. And like I said, we will send you some more information following this webinar, but if you do have additional questions that we did not have time to address, you can send an email to the presenter herself, which is hilda.parra, P-A-R-R-A, @cgg.com, or you can send a question to gs.solutions@cgg.com. And again, we thank you for joining our overview of our velocity modeling application in regards to pore pressure prediction. Thank you.